Good evening. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and in this segment, I'm going to talk about another mathematical subject. But before I go into the topic, you've already heard me do general math, algebra, trigonometry, differential calculus, vector calculus. And tonight is going to be no different. So the title of this evening's video is What is Linear Algebra? Now, when we talk about linear algebra, it's basically the field of mathematics that is universally agreed to be a prerequisite to a deeper understanding of machine learning. Now, although linear algebra is a large field with many esoteric theories and findings, the nuts and bolts, tools, and notions taken from the field are practical for machine learning practitioners. Now, with a solid foundation of what linear algebra is, it is possible to focus on just the good or relevant parts. Now, part of linear algebra, and I took linear algebra at Anne Arundel Community College a long time ago. What you get in this course is the mathematics of data. You also get linear algebra in the field of statistics. Now, linear algebra also underlies many practical mathematical tools such as a Fourier series and computer graphics. Now, when you deal with linear algebra, one thing that you're going to be concerned with, because it does deal with machine language and computers, is matrices. Because you're going to have 2x2 matrices, you're going to have 3x3 matrices, you're going to have row reductions, you're going to have eigenvalues, eigenvectors, you're going to have a system of equations. Now, again, when we talk about linear algebra, it's a branch of mathematics, but the truth of this is that linear algebra, again, is the mathematics of data. Why? Because matrices and vectors are the language of data. Linear algebra is about linear combinations. That is, using arithmetic on columns of numbers called vectors and arrays of numbers called matrices to basically create new columns and arrays of numbers. Now, linear algebra is the study of lines and planes, vector spaces, and mappings that are required for linear transforms. Now, it is a relatively young field of study, having initially been formalized in the 1800s in order to find unknowns in systems of linear equations. Now, a linear equation is just a series of terms and mathematical operations where some of the terms are unknown. Now, again, when we talk about systems of equations, you're going to have equations that have two unknown variables, or you'll have them with three unknown variables. Now, when you try to find the unknowns, what you do, you isolate one variable to get the other. And then once you have the answer with the other variable, you take the answer that you got from the other variable and substitute it back into the equation to find the variable that you didn't get. Now, basically, when we deal with linear algebra, again, we talk about the application of linear algebra in computers. Again, it's more than just the implementation of linear algebra operations, because it deals with code libraries. It also includes the careful handling of problems of applied mathematics, such as working with the limited floating point precision of general computers. Now, computers are good at performing linear algebra calculations and much of the dependence of graphical processing units known as GPUs by modern machine learning methods such as deep learning because of their ability to compute algebra equations very fast. Now, efficient implementations of vector and matrix operations were originally implemented in the Fortran programming language. Now, I took Fortran way back in 1985. It was a language used for engineering. And back in the 70s and 80s, Fortran had a lot of code. And the code, for the most part, ported from the linear algebra implementations. And of course, when you dealt with program, basically, Fortran underlines much of the linear algebra performed using modern programming languages such as Python. Now, the three popular open source numerical linear algebra libraries that implement these functions are Linear Algebra Package or LAPACK, Basic Linear Algebra Subprograms or BLAS, a standard for linear algebra libraries, automatically tuned linear algebra software known as Atlas. Now, often when you are calculating linear algebra operations directly or indirectly via higher order algorithms, your code is very likely dipping down to use one of these or similar linear algebra libraries. The name of one or more of these underlying libraries may be familiar to you if you have installed or compiled any of Python's numerical libraries, such as SciPy or NumPy. Again, when we talk about applications of linear algebra, there's matrices in engineering. And basically, the branch of engineering that uses a lot of matrices and systems of equations, because you can take a system of equation and turn it into a matrix, but you have to know how to mechanically compute the matrices. In fact, if you utilize matrices, you can compute the unknown variable by using RREF. That's row reduction formulas. Now, again, matrices in engineering, like electrical engineering, such as a line of springs, graphing networks, such as analyzing networks. These are all applications of linear algebra. Markov matrices, populations, and economics, such as population growth, linear programming. If you're taking industrial engineering, you're going to utilize a lot of linear programming and optimization because linear algebra is part of the simplistic or simplex optimization method. Fourier series. Fourier series is utilized in differential equations. Well, linear algebra for functions is widely used in signal processing. If you're an electrical engineer, you will get into signal processing. Linear algebra for statistics and probability. And if you're a surveyor, and I did surveying, you utilized a lot of least squares for regression. Computer graphics, such as the various translation, rescaling, and rotation of images. Now, another application of linear algebra is that it is the type of mathematics used by Einstein in parts of his theory of relativity, which is E equals mc squared. Specifically, tensors and tensor calculus. Now, he also introduced a new type of linear algebra notation called the Einstein notation or the Einstein summation convention. Now, again, when we talk about linear algebra is the branch of mathematics. But the truth of the matter is that linear algebra is the mathematics of data. where matrices and vectors are the language of data. And that concludes this topic on linear algebra. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some hard-hitting content on YouTube, more or less on a red pill, political formats, check out the 401 Talk Zone radio show on YouTube. And I'm also going to get the radio show going again, because on a radio show I can present content that's too hot for YouTube. 215-383-5785 is the number. And of course, if you can't find me on YouTube or Blog Talk Radio, you can check me out on Twitter, MeWe, and Parler. Once again, I thank you for listening to this edition of the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious night.